This video will prove a nice fact. It says the sum of two twin primes, p and p plus 2, is divisible by 12, provided that p is at least 3. Okay. So what are twin primes? Hopefully you can see it from here. They're primes that differ by 2, if p is at least 3. You know, like 3 and 5 differ by 2. 3 and 5 are twin primes. 5 and 7 are, because for 3 and 5, they're both prime, and they're consecutive primes. You know, we know that 4 is not going to be a prime. They differ by 2. 5 and 7 differ by 2, and they are primes. 5 and 11, they're both primes, but they don't differ by 2. 7 and 9, they differ by 2, but they're not both primes. 8 and 10, they differ by 2, but they're not primes. 11 and 13, they differ by 2, and they are primes. What they're saying is, if p is bigger than 3, like 5 and 7, says the sum, which is 12, is divisible by 12. Does 12 divide 5 plus 7? Yeah. 11 and 13. Does 12 divide 11 plus 13, which is 24? Sure does. 17 and 19. Those are primes that differ by 2, and 12 does divide their sum, which is 36. Now, for the record, 12 does not divide 3 plus 5, which is 8. 12 does not divide 8. Now, the proof is pretty simple. All prime numbers are of the form 6m plus or minus 1. If p is 6m minus 1, then p plus 2, well, that would be p plus 2, which is 6m plus 1, which is okay. If p is 6m plus 1, then p plus 2 would be p, 6m minus 1, plus 1, excuse me, says it right there, plus 2, well, that would be 6m plus 3. And no, you can't write 6m plus 3 as 6m plus 1 or 6m minus 1. So this case cannot be possible. So pm is 6m minus, p is in the form 6m minus 1, and p plus 2 is of the form 6 times the same m plus 1. Okay, let's get our hands dirty. Let's add the 2. Well, p is 6m minus 1, and p plus 2 is 6m plus 1. That equals 12m. And 12 divides 12m. 12 divides this, but that implies 12 divides anything that equals 2 or 12m. And 12m is equal to the sum of the two consecutive, or the two prime numbers that are bigger than 3. Very straightforward proof. All you have to know is that every prime is of the form 6m plus 1 and 6m minus 1. And if p is 6m plus 1, then p plus 2 can't be a prime. You can call it p if you want, but p plus 2 is not a prime, because it's going to be a multiple of 3. It's going to be on the 3 times table. The problem is, if you're on a 3 times table and you're not 3, then you are not prime. Okay, this is on the 3 times table. 3, 6, 9, 12, etc. And p cannot be that number. P is bigger than it. Well, p can be this one or this one or this one. P cannot be one of them. So we ruled out, this case, and we added their two values, the value together with the value of p, the value of p plus 2, and we concluded that 12 does divide the sum. Nice, quick, easy proof. If you want to see proofs like this, subscribe to my channel. I do proofs all the time. See you guys in the next video. Don't forget to subscribe and to watch and learn.